And here is we starting with the whole slice image. And then we break down this whole slice image into many, many small pieces. And we feed these small pieces into the big GAN. And the big GAN try to understand how these small pieces working together, how the pixel within the piece are working together, and which pixels can be removed, which pixels can be kept. And then they, after finish all of this simulation, and then we take the big GAN results to generate digital representation of the whole slice. And then we feed this information into the convolutional neural network. And in the end of the day, so we will have models and provide two sets of information. The first, how severe the necrosis is and where the necrosis was occur. The paper has already been published and it shows here. So another GAN method, and I certainly have a lot of the passion about it, called the cycle GAN. And it was so interesting. Now let me just ask you, if I say you see a horse, I let you guess what the zebra going to look like. And you probably have some sort of general idea what the zebra going to look like. If you go to the campus, take a photo today, and then when I ask you questions, well, what is the picture going to look like during the winter based on the picture you take and today? And you might have some sort of the general ideas based on the photo today, right? And if we even can go a little bit more beyond, right? And let's just say angry cat, just like Yvonne did, put into some sort of the prompt, and you can come up back in an image. So what is that? This is what we call the translational science, and how you can translate the results or observations from one domain to another domain. So this is exactly what we did. We first did it using this technology to look at the genomics data translations and from the one organ to another organ. And we have 10 organs from the both male and female and from the full development stage. And there is no drug treatment involved, just the healthy rats. And we have a pretty large data set, and we ask questions. If we look at the gene expression data from the liver, is that going to be able to predict what's happening in the kidney or what's happening in the heart? So this paper also already being published and very successful. Actually, it's durable. And then we take a step further. We say, okay, let's look at the drug treatment. If I treat the animals, I only look at the liver, and I have the liver gene expression data. Can this data be used to predict what's happening in the kidney? And or vice versa. And we did a very extensive work, and this paper is basically already accepted by the digital medicine. It's very good journals. And another work we are doing is to translate the data from the one genomics platform to another genomics platform. Now think about, during the 2000, the microarray technology probably is the only game in town. Everybody uses the microarray technology. And I heard that maybe American confirm with it. It's a company spend about $1 million every year to generate the genomics data using the microarray technology. And then suddenly we switched, become the RNA-seq. So what are we going to do with the old genomics data? Throw away or redo the whole thing using the RNA-seq? Of course not possible. So this is the translation become very important. So that what we are doing right now is we're using the cycle GAN. Of course, we engineered and the cycle GAN to translate the microarray data to the RNA-seq or vice versa. And so in that way, we will be able to leverage your past the investment. And the last project, and this is still ongoing. All right, so this is end to my final slides now, and we do have a program called the AI Program for Toxicology, or the AI for Tox, and you can read more about what we do, what we are doing. And in the bottom, there is a link. Unfortunately, any link from the FDA is very long, you'll never be able to remember. So the easy way to get our web page, just type in AI for Tox on the Google. It will lead you to our webpage. Essentially, we have several initiatives. I talk quite a bit about the animal GAN. I touch on a little bit about the Translate AI initiative as well as the pathology AI. Actually, the most efforts we spend is on the BirdTalks. It's a large language models to dealing with the FDA documents. So this is clearly deserves the whole presentations. And we also have another initiative called the Safety AI. We did not start it. Actually, it was the reviewer from Cedar asked us to develop a suite of the models to predict the toxicological endpoint, which are important in the drug review process. So I think that we are really living in the fast-moving era of the AI, and the new algorithm, new methodology, new ideas keep coming up. I think the challenge is not about the AI themselves. It's how we understand human brain works. So we will be able to develop the AI to simulate or mimic how we digest the information. So our only limitation is our imagination. So for that, I really want to thank my team. And my team is very young, and it's definitely not lack of the imagination. And we have a college student. We even have one high school student. And it's my firm belief, and AI is a young people's future. And we're also very fortunate to get a lot of the support from our sister centers. And I think I'm just stopping here, leave 5 minutes for questions. Oh, by the way, I just make a self-promotion, make one announcement. I will be the first plenary speakers talk about the generative AI for toxicology and drug safety in the ACT meeting, American College of the Toxicology, which we're going to be the Austin in November. That was very close by, 2 hours away. I hope to see some of you there.
Wait, thank you. Quick question and clarifying one. So your animal GAN and a number of other GAN models are focused on predicting intermediate phenotypes. And a lot of the traditional models, QSAR or something else, is thinking more of the end phenotype, DILI or endocrine disruptor or not, this or that. And you're trying to generate intermediary things that then will require human interaction to actually make a final conclusion. So if GAN is so good, why not go all the way to the final prediction?
Excellent comments, excellent comments. I get a short answer, and I know have other. There is two types of the AI, right? Predictive AI and the generative AI. Today I only talk about the generative AI. Predictive AI normally and predict the final results. If you look at the study, you give the chemical, give the rats, you some readout, and based on the readout, you assess whether it is toxic or not. So the traditional predictive AI all the way predict whether it's toxic or not. But the generative AI, what we are doing right now is to generate the intermediate experimental data. Now, it's not saying the predict AI cannot predict intermediate data. We did, and there is another whole set of the story. But basically, animal GAN was outperformed the conventional predict.